So in yesterday's lesson, we took a look at multiplying binomials together. Today we're going to take a look at some special products. So I know how to expand a squared binomial, and I know what is special about multiplying brackets that are a sum and a difference. So these are just some special situations that are good to talk about. So when we recognize them, we know an easier way to solve them. So there's two different types of products that we're going to look at. We're going to take a look at what happens when we square a binomial. And you guys, I think, had a question yesterday on this that some of you were asking about. So some of you will already have an idea about this. And then what happens when we multiply two binomials together where the signs are the opposite? So 2x plus 5 and 2x minus 5. So let's take a look and see what happens here. When we're squaring a number, it means that we multiply it by itself. So 5 squared means 5 times 5. So according to that, if we have something like 2x plus 5 squared, then that 2x plus 5 multiplies by itself. So 2x plus 5 times 2x plus 5. So when we see something like this, we can rewrite it like this, and then we can go ahead and do FOIL on it. So if you think back to what we did on yesterday's lesson, we're going to multiply through here. So 4x squared plus 10x plus 10x plus 25. So we end up with 4x squared plus 20x plus 25 when we collect like terms. One thing I do want you to notice there is that when we square a binomial and we do FOIL on it, we end up with the same middle term here. So that middle term shows up twice. That's going to help us come up with a little bit of a shortcut here. Okay? So we've got an easier way, a quicker way that we can get there. We're just going to try and see if we can find the pattern. So if I try and square x minus 3, that's going to be x minus 3 times x minus 3. Then I do FOIL. So I'm going to get x squared minus 3x plus 9. So there's that situation where these two terms are exactly the same, and that's because of the squaring part. And at the end, we get x squared minus 6x plus 9 as our answer there. So let's try the next one, 2x plus 6. So we write it out twice. When we do FOIL on that, we're going to get 4x squared plus 12x.
Mr. Cool, call 500, please. Mr. Cool, call 500, please.
Plus 12x plus 36. And again, there we have the same middle terms here. Shows up twice. And when we simplify this one, we get 4x squared plus 24x plus 36 as our answer there. Well, what happens if we have ax plus b and we're squaring that? So that means we're going to get ax plus b times ax plus b. This is going to be weird with all these letters. If I multiply ax times ax, I'm going to get a squared x squared. And then I'm going to have abx. Remember, I'm going to write the variables in alphabetical order. So I'm going to get another abx. So there you can see we got the same middle term again. And then b times b is going to give me b squared. So I end up with ax.
Ms. Waukee, please call attention 504. Ms. Waukee,
A
504.
squared x squared plus 2 abx plus b squared. So that's what I end up with as my answer there. So here's the shortcut. If I've got some expression here that's being squared, I take this first thing and it gets squared. So I square it first. Okay? If I'm trying to get the last term, I take the second term in the bracket and I square it. That's where the b squared is. And then to get the middle term, I multiply the two terms in the bracket. So I multiply ax times b, and that gives me abx. And then I multiply by 2. So I multiply those two terms together, and then I double them. And the double them is just the 2. Okay, so we're going to try some questions with the shortcut. See if we can handle these. So I've got 3x minus 2 squared. So I'm going to square the first term. So if I do 3x squared, okay, and then I've got plus 2, and then I have to multiply the two terms in the bracket together. So there's my a and my b I'm multiplying together there. So ax times b, and then I've got plus, and then I've got minus 2 squared on the end. So when I simplify that, 3x squared, I have to square both parts. So 3x times 3x is going to give me 9x squared. Now, I've got to be careful in the middle here, because when I multiply these three numbers together, 2 times 3 is 6, times negative 2 is going to give me negative 12. And then I've got an x with that. And then negative 2 squared is going to be positive 4. So that's the answer that I get. So the question is, can I go from here right across to there? So in this one here, I have to square the first term. So 5x times 5x gives me 25x squared. Then I have to do 5x times 1. So these guys are multiplied together. That just gives me 5x. And then I double 5x, and I get 10x. And then the last term, I square the 1, and I get 1. That's what my final answer is going to look like there. In these questions, it wouldn't be a problem to write out 5x plus 1 times 5x plus 1 and do FOIL on it. I'm just showing you an opportunity for a shortcut here. So in this one here, square the first term, that's x squared. The middle term, if I multiply negative y times x, I get negative xy. And then I times that by 2, I get negative 2xy. And then I square the last term, so negative y times negative y is going to give me plus y squared. So it's going to look like that. Okay, so let's see what happens when we multiply a situation where there's a binomial that's adding and another one that's subtracting, and they both have the same terms. The only difference is that sign in the middle is plus or minus. So if I do FOIL on this, these binomials, I get 4x squared, then I've got 2x times minus 5 minus 10x, and then I'm going to have plus 10x, and then I'm going to have minus 25 when I multiply the 5 times negative 5. And an interesting thing happens here when we've got different signs. Those two look similar, but one's negative and one's positive. So they actually cancel each other out. They create a 0 there. So we're just left with 4x squared minus 25. And in the next one, I'm going to get 16x squared plus 4x minus 4x minus 1. Same thing happens in the middle. So I'm just left with 16x squared minus 1. In this last one, I get a squared minus ab plus ab, and then minus b squared at the end. And even with all variables there, you can see in the middle, those two are going to cross each other out. So we get a squared minus b squared. So think about when you look at that, what did you notice when we multiply those things together? So we just discussed it, but when we use FOIL, the middle terms always cancel each other out. So we can actually just multiply the first terms and the last terms when we see a situation where the brackets are exactly the same, but the signs are different. Okay, and notice that the final answer always has a minus sign in the middle, and the terms are perfect squares. So these expressions here we call difference of squares. So here's an example of difference of squares because we got a perfect square, and there's the difference in the middle. What do you think the brackets look like before you got that answer? I'm going to pause and see if you guys can figure it out. I'll put my answer down. So we end up with 3x minus 7 and 3x plus 7. 3x times 3x gives 9x squared, and negative 7 times positive 7 gives us the negative 49. And it doesn't matter which order you write the brackets in. You could write the 3x plus 7 first, then the 3x minus 7, and that's going to be a correct answer as well. So we'll try some of these in class tomorrow. Thanks.